My name is Sudesh Sivarasu. I'm a biomedical engineer. I work as a senior lecturer in biomedical engineering at Faculty of Health Sciences. And my latest invention is on patellar surgery assist device. The device is called Patrick because it is used as an accessory for MPFL reconstruction surgery. If I want to make two holes inside the part of a body for attaching something like an elastic filament onto a rigid body, and if I make these two holes in a way that's going to cause fracture, that is not desirable. So what I want to do is I want to make an accessory which can make two holes parallel, and this is very essential for the fracture not to propagate further. So this device will basically fit around the knee, and that will help the surgeon to make two drills. The medial patellofemoral ligament is the primary ligament that holds your patella. If you know what the patella is, it's the kneecap. So the kneecap can get easily dislocated due to sports injury. And whenever there is any kind of impact on the knee from the medial lateral side, that is from the inside or from the outside of the body, there's a good chance that the patella or the kneecap can move out or can dislocate. When it dislocates, the ligament that is attached will get stretched. We call this as laxity or elasticity of the ligaments. The ligament's laxity can be disturbed, and the only way of reproducing the same patellar orientation is by doing a reconstruction surgery, which is bringing this patella back to its original position by reducing the laxity of the ligament. So this is done by harvesting a ligament from other part of the body and reattaching the ligament onto the patella to hold back its position. So it is the patella fits very well inside the knee condylar groove, and if even a couple of millimeter variation, the patella can shift out either on the inside or on the outside, or either the medial or the lateral side of the joint. And so if the surgery is not done properly, the attachment of the ligament onto the patella, if it is not done properly, there's a good chance that the attachment can come out very easily. So we are looking at ways to probably get the surgery done more in an efficient manner, which will require less expertise from the surgeon to actually drill the holes. In fact, the drilling of the holes becomes the crux of the attachment. So if the holes aren't drilled properly, there's a very good chance that the ligament could come out, or the ligament could introduce fracture on the patella. So if both are not desirable. So we are making a device. This Patrick is basically to help the surgeon to make proper drills onto the patella. I wanted to make a low-cost device. So all these medical surgical equipments are imported, and I really wanted to break this crux of importing devices, and we want to make locally designed and manufactured devices. And at the same time, we also wanted to look at probably a disposable device. And the orthopedic surgeon, arthroscopic surgeon, Dr. Sudesh came to me with the problem of drilling parallel holes in the patella, and we designed the solution along with the surgeon to make affordable solution for developing economies. And Patrick is the solution for this. Well, so the first and foremost was the manufacturing technique. We were kind of confused about which, I wouldn't say confused, but we were not sure which manufacturing technique to use, because this is a very small device. and this device will have to go into multiple iterations before it can be finalized. So if I choose a traditional manufacturing method, I might end up spending a lot of money on getting my first product before even I can try it, before even I can go into in vitro testing. And so this challenged us in terms of the design thought, the design thinking process, and we had to go into an alternate manufacturing process in terms of getting the solution out, and that was the biggest challenge. And then we chose 3D printing as an alternate route for this, and it also fit into our global perspective of making things cheaper. So we used this as a first step to get the prototype of or a proof of concept of the device. But then we found that it might be leading into the next question. I found that I was trying too much on a single prototype, so I had to cut short on the actual requirements of the design. So manufacturing with plastics, manufacturing with metals, I was not able to combine these two together. So that was again another bottleneck which we had to overcome. So that was adapted into the design, and we made the entire structure out of plastic. I think the future of a device like this, especially if it is a disposable device, we would have tremendous potential. It'll be first of its kind to come out in the market for a specific clinical or a surgical requirement. Second, this is a disposable device, and potentially this can, because of the manufacturing technique that we are using, it can be used in most of the developing countries without really having to have a huge impact on the cost of the device. Then I also see this as a similar technique could be used for other surgical procedures as well, because if you look at most of the surgical tools, they're all or about 80% of all the surgical tools are reused. So we are going into one step further away from it, trying to make at least one of the device as a disposable device, and we are seeing that this could, something of this order could actually change the way surgical procedures are done in future. So we are kind of opening up a new avenue in surgeries. The social implication, one, I think this is a wonderful opportunity for job creation for a locally manufactured device like this. And second thing is, all these smaller devices, cost of these devices count into the total healthcare expenditure. And if we can reduce cost of these devices to an extent, we can also reduce the total healthcare expenditure, which could be one step low on your tax in a larger sense. So that's a holistic view, but it will reduce the surgical expenditure by a few thousands.
So looking back, would you do anything differently?
Yes. First and foremost, I think what most inventors get stuck into is the idea of invention, and they try to get everything in the single invention. I think that's something that I wouldn't do, or I would do differently if I go back on this, because I had almost all the specifications. I was thinking through all the specifications on a single design, and that was not possible. So my next target was to move into making a minimum viable product. Basic, just functional, and proof of concept. If that works, then I can upgrade it. So that took about a year to realize, but that's something that I would have done differently if I had to restart with it now.
Do you have any advice for potential inventors?
Yes. Okay, see, potential inventors, like from my personal perspective, do something that is useful, and if it is anything which is useful, if you think there is a potential use for that, be passionate about it, and yeah, don't give up, because many times we have seen that even with my own device, first iteration it failed, it just goes off, you get demotivated. So we got in about the 10th iteration, this device came, we started to give out a possibility that it might work. So persistence, perseverance is what I would say. I think I'm very passionate about serving people, and I think you can make a difference with whatever you're doing if you're really passionate about it. And I feel that healthcare expenditures are primarily due to large imports that we make. Right from, in a country which has 95% medical device imports, we import right from surgical gloves to IV lines to heart valves and everything. So all these adds on to the healthcare costs. So I want to make a difference in making locally manufactured medical devices so that the cost of these devices can go down.